Hello everyone, now we are going to solve the next question on the design of the flywheel rim. In the question, what is given that consider the following parameters. There are four statements which is given in this question. We have to find out which of these parameters are used in the calculations of the diameter of the flywheel rim. If you carefully see the diameter of the flywheel rim, that means you can get the diameters of the flywheel rim using the formula of mass moment of inertia. We all know, if I'm going to write the mass moment of inertia, that is I is equal to mk square, and where k is nothing but the radius of gyrations. And for the rim type flywheel, it is equal to r, or you can say this is the half of the diameter. Okay, so this is about the moment of inertia, and we all know that v is equal to, when we solve the questions based on the design of the flywheel, we have seen the derivations of the design of the flywheel rim. We get the relation, that is v is equal to sigma upon rho. We got the relation sigma upon rho, that is basically we get from the design when we design the flywheel rim. Okay, when we design the flywheel rim, we got these relations. So, and you can say there is the velocity and stress, that is nothing but the hoop stress, are in relations with the density of the flywheel. You can write as mg is equal to weight of the flywheel, and where m rho is equal to mass upon volume. So we can say that mass is equal to rho into v. Okay, so basically mass and density are related to each other. So we have to consider these statements, that limit of the peripheral speed. Okay, this means it is talking about v, and this is centrifugal stress sigma, and coefficient of fluctuations of speed is cs, and weight of the flywheel ring, that is mg. Okay, so when we have seen that here, we can get, when we design the flywheel rim, we got the velocity, centrifugal stress, and we don't have any coefficient of fluctuations of speed in relations, and weight of the flywheel rim, that is mg. You can write it as rho into volume into g. Okay, so basically that this is talking about the density. So of course fourth statement is also correct. So which of these parameters used in the calculation of the diameter of the flywheel rims? That is nothing but the design of the flywheel rim. Okay. So when we design the flywheel rim, we got three terms, that is velocity and the stress and the density, that means the weight of the rim. Okay, there is no terms in the formula coefficient of fluctuations of speed. So only 1 to 4 statements are correct. So option D would be the correct answer for this question. Okay, it is directly indirectly saying about the design of the flywheel. Okay, so this is what about the design of the flywheel. Options D would be the correct answer. Okay, the maximum value of sigma can be, it can be bearing strength of the flywheel, sigma b. Maximum value of sigma is sigma b, and generally it is considered as the hoop stress, which is equal to sigma is equal to T upon A, where T is the tension, okay, and A is the area of the flywheel. Okay, and we all know that at medium speed flywheel with spokes is considered, and at the high speed disc shaped flywheel we consider. Okay, because disc shaped flywheel is having high energy storing capacity and also known as the best flywheel. Okay, and if I want to ask you that the highest energy storing capacity, so it would be equal to half I omega square. This is the highest energy storing capacity. Okay, so for this question, option D is the correct answer. I hope you will get the solution. Thank you.